All right, everybody, let's get started, shall we? Cool. Welcome to the first track. I hope everybody's morning is going well. Today we'll be taking a look at embedded programming made easy, kind of looking at MicroPython and getting comfortable with that. So my name is Derek. I work for OrderSlip. It's a bitwise company. We do a lot of mobile development and whatnot. That's kind of my day job, and then by night I'm sort of like a Fresno technology community vigilante. I run the Fresno Python user group. I started that in 2015. I sit on the board for 59 Days of Code, if you're familiar with that competition or the numerous events that we do there. And then a couple years ago, I co-founded a hackerspace called Root Access, where we do all sorts of tech community stuff, tools and equipment and meetups and all kinds of stuff. So my background is mainly in software and web development. Didn't really get super into hardware until this thing called the Raspberry Pi came out. And it kind of came on the scene in 2012. It's just a small Linux computer that has GPIO pins on it. That's these pins right along the side here that let you interface with hardware. And it's sort of like if a regular computer and a microcontroller were to merge together, you'd have something like the Raspberry Pi. It runs Linux operating system, and you can hook up sensors and motors and all kinds of stuff to it. For the first several years, I pretty much used it as a computer and didn't get into hooking anything neat up to it. But when I did finally kind of catch that bug, I quickly realized that for some of the projects that I wanted to do, having a full computer with a full operating system just kind of seemed like overkill, and it was a little much. And so as I was looking around, I came across this thing called the Arduino. And the Arduino is a microcontroller. It doesn't run an operating system like a computer does or like the Raspberry Pi does. You write code, flash it directly onto the board, and it will just run that code over and over and over again. And that's what microcontrollers are for, right? They're meant for doing a task or a set of tasks again and again and again, right? Sort of like the Energizer Bunny. It just keeps going and going and going. And the Arduino was really cool. And I ended up with this to-do list where, newbie me, I needed to learn how to do electronics and also learn more about writing Arduino C, how you program the Arduinos. And I didn't have the drive to learn two things. I would have really preferred to learn one thing and use knowledge that I already had for the other thing. And the knowledge that I already had was, I know Python. I really wanted to use Python to do some cool hardware stuff, and that's where MicroPython comes into play. So MicroPython is a variant of Python specifically for embedded devices for running on microcontrollers. There's a number of different implementations of the Python language. MicroPython is one. The other implementations let you run on the JVM for Java or the .NET platform. And so as I was getting into this, I found myself really enjoying using Python for hardware. So looking at the hardware that's available, interestingly enough, you'll see a Raspberry Pi up here because there's a project aimed at running MicroPython on the bare metal of a Raspberry Pi, turning it into less of a computer and more into an actual microcontroller. My favorite board is the ESP32. I use it in a ton of different projects. It has Wi-Fi built in. It's got a really decent processor, lots of memory available, and tons of GPIO pins. The Microbit is a project that, or is a board that the BBC released some years ago. If you want to check it out, it's a really neat little learning platform, and in the Makerspace track, we're doing some robotics with the Microbits. This little guy here in the middle is the ESP8266. It's sort of like the little brother of the ESP32. It preceded the ESP32 and is really commonly used kind of as a Wi-Fi module. So you can take an Arduino that doesn't have Wi-Fi built in and wire it up to this little guy, and now you can have an IoT device. And then on the bottom right here, is the Pi board. It's a board specifically made to run MicroPython. So you can't talk about MicroPython without also talking about CircuitPython. CircuitPython is maintained by Adafruit. They are an electronics company based out of New York. They're super awesome. They have tons of articles on learning hardware and coding and all sorts of cool electronics projects. They make a lot of their own custom hardware, including things like these. So top left here is the Gemma M0. This board, the M0, is what's running in my hat right now, controlling the LEDs. So I have that hooked up to a battery pack, and it's just kind of going through some rainbow colors, and it's really easy to use. The middle one here is called the Pi Gamer. It's a platform for making your own games in MicroPython. It's another really neat piece of hardware that they've released. And then somebody, of course, went and ported an NES emulator to it. So on mine that I have a bunch of old NES games that I have with me anywhere I go, which is really going to come in handy tomorrow when I'm flying down to San Diego. On the top right is the HoloWing M4. It's a board that lets you control an eyeball. Really neat for like cosplay projects. Halloween is coming up, so there's a lot of different uses. People have taken those and put them in their pumpkins, put them in masks, all sorts of things. I kind of want to get like a clown mask and set it up at the hackerspace with these inside of it. Find like an It mask would be cool, put it in our window. The bottom left is the Circuit Playground Express. It's another learning platform that Adafruit has made. It's got a bunch of LEDs, a bunch of GPIO pins, some buttons, lots of sensors. It's got a temperature sensor. It's got a speaker and a microphone, all kinds of stuff. And it's kind of neat to play around with. So we'll be taking a closer look at that one in a little bit. And then on the bottom right here is the Neo Trellis M4. And this is a board with 32 LEDs. Every LED is a button that you can push. And the board has some really nice audio processing hardware. One of the common beginner projects for this is making a soundboard. So like a Halloween or a Christmas soundboard, there's Doctor Who and Star Trek and all sorts of little projects that you can put on this, and it'll do some cool color changing things. Push a button, it'll play whatever sound is mapped to that button. And people have done like neat display things. This is sort of like a sand demo. As he rotates it around, the lights kind of fall as if by gravity, which is kind of neat. So the difference between MicroPython and CircuitPython. MicroPython is kind of the genesis of all of this. It came on the scene some number of years ago, and it's Python designed for microcontrollers, right? Running in low-powered environments. Neat. All right. Now that everybody's phone is done wigging out. CircuitPython actually started as MicroPython. MicroPython is fully open source, and Adafruit took that code base and copied it and made a bunch of changes so that it would work better on their hardware, and also to make it easier for education, right? CircuitPython is really geared towards education and learning environments. Adafruit has spent a lot of time making certain things easier to do in CircuitPython versus how you would do it in MicroPython. I sort of see MicroPython as a little bit lower level than CircuitPython. There's a lot of nice wrappers around sensors and other pieces of hardware in CircuitPython. Which one you use will depend on what hardware you're using. If it's any sort of Adafruit board, you're going to be using CircuitPython. And pretty much anything else is going to be regular MicroPython. And so as we go through this, both MicroPython and CircuitPython will be mentioned. When I say CircuitPython, I specifically mean Adafruit's fork called CircuitPython. So different common tasks that you might want to do with a microcontroller with MicroPython. Programming LEDs is one of the most common, and a lot of boards have LEDs built in. It kind of gets you in and interacting with hardware the quickest. There's a lot of different designs and effects. There's LED strips, like you see here. There are LED matrices, just a big grid of LEDs. We have one of those over in the Makerspace track that you can check out, running some different animations and scrolling text and whatnot. It's a lot of fun controlling LEDs and doing things like whether it's for some holiday decorations, maybe you just want a certain aesthetic in your living room. I'm really into cyberpunk, so lots of like pinks and cyans and blues. Want to get a lot of those set up at the hackerspace. But it's a really easy way to get into hardware and get immediate visual feedback on what you're working with. So something else that's really common is connecting to sensors. This is somebody that set up a heart rate monitor on their finger. It's using MicroPython on an ESP32 to just kind of scroll his heartbeat and display his heart rate. Is really neat. There's all sorts of different sensors from body sensors like this, environmental sensors, things like temperature, humidity, barometric air pressure. There's like air quality sensors, light sensors, sound sensors, all kinds of stuff that can be used as kind of a basis for a larger project. And then of course there's building robots to kill all humans, which is one of my favorite pastimes. I legitimately I would be fine if I played a hand in bringing on the robot apocalypse. That's kind of one of my life's ambitions. But there's a number of different kits that let you build sort of little like robotic cars like this that have 2 or 4 wheels, and maybe you control them and drive them around like they're doing here, making them autonomous using a distance sensor so that it can roam around a room and not bump into walls, things like that. And kind of a key thing is that everything you do with robotics on something like this totally translate to kind of industrial level robotics and automation, right? You're still controlling a lot of the same kinds of motors. They're usually just bigger. Stepper motors and servos and DC motors. It's really just kind of a matter of size. And then of course, if you have a board with Wi-Fi, like the ESP32, or you take that Wi-Fi module and put it up on another microcontroller, it opens up a whole new world of IoT applications, right? The Internet of Things, smart devices that connect to the internet, that collect data and report to a central server, or maybe they can be controlled remotely via the internet. And we'll take a look at an example of an IoT project towards the end of this talk. But this is kind of a really neat thing because it lets you build projects and do things kind of without having to be there, right? It's a lot of automation, setting things up to run on their own, and you can check in and make sure that it's still running from wherever you are, right? Collecting sensor data and things like that. This is probably one of my favorite applications of, since I've been getting into hardware and electronics. After talking a little bit about MicroPython versus CircuitPython, and seeing a little bit of what you can do with them, some examples of common tasks, it is time to take a closer look and actually write some MicroPython. So, when you want to write MicroPython, the most common question is, how do you get started, right? Where do you start? And there's this editor called Mu, which was built for MicroPython. It's simple, has a really simple UI, it's easy to learn. It supports MicroPython on the BBC Microbit, as well as all of Adafruit's hardware. And you can use it as just a regular Python editor if you want. It's completely cross-platform, Windows, Mac, Linux. You can run it on a Raspberry Pi. Check it out at codewith.mu. Is their website for it. And that's what we'll be using to write some code on the Microbit. Now, before we get into some of the hardware, I mentioned LEDs are a really easy way get started. And just wanted to touch a little bit on RGB LEDs. The way that they work and kind of the way colors on computers work in general is that all colors are made of a triplet of red, green, and blue. And any color that you get is just a combination of each of those colors at different intensities, right? So red would be red all the way maxed out with 0 green and 0 blue. You define the colors with a number between 0 and 255, so 256 total values for each color, which gives you 16.7 some odd million possible colors that you can make with these LEDs and on computers, right? That's how many colors our screens are capable of displaying. Some of the colors are really, really close together, so it might be hard to tell, but they are there. This example kind of shows how that works. You have the blue, the red, and the green. And you'll notice that when all three of them are on, if you look around the edges, it's sort of white, right? And so that's how you define white, is all three maxed out. Black would be all three of them at 0, right? No color at all, the absence of color. So this is the circuit playground. And we'll be taking a look at this. You can see the LEDs here. Let's see, let me grab this. There are things like a temperature sensor there. There's a little light sensor there. There's a speaker there. There's a microphone right there. You can kind of see the symbols on the board showing you what each of the components are. And this is really meant to be used as a learning platform to learn how to work with some of this hardware. You might use this board directly in some projects. A lot of people do. You might prototype with this and then go get some different speakers, different set of LEDs, whatever for your actual project. This is kind of a listing of everything that's there. So you've got buttons and all the sensors and lots of connection pads to wire hardware up to it to control that hardware. So let's take a look at some hardware. All right. Okay, so here I have, is this working? Yeah. All right. So I've got a Circuit Playground Express here. It's plugged in. It's not doing anything yet. And one of the examples that we'll take a look at is color cycling. So in Mu, I'm going to, so this is the Mu editor. It has different modes for, like I mentioned, the Adafruits hardware and the Microbit. You can write Python 3 with it. It's just a really simple editor. So if I open up, all right. So with the Circuit Playground Express plugged in, it appears as a drive called CircuitPy on my laptop. And inside there is a code.py file. Code.py, some versions of MicroPython will run main.py, but that's kind of where all of your code lives in that file. And you can have other Python files in there, but that's the entry point. That's what it starts running when it boots up. So if I open up that code.py, there's nothing in there. So let's paste in this script here. Zoom in a little bit. Is that readable? All right. So kind of walking through this script, right? We start by importing the time module and the Circuit Playground Express module. We'll use both of those further down. And then we define a set of colors, right? So I mentioned LEDs are red, green, and blue. So red would be 255 red, 0 green, and 0 blue. Green would be 0 red, 255 green, and 0 blue. And then blue would be 0, 0, and 255 blue. And then kind of mixing those colors together, if you want something like cyan, you mix green and blue. Yellow is a mixture of red and green, and purple is a combination of red and blue. So we're going to take these colors that we've defined, and we're going to put them into a tuple so that we kind of have a list of all the colors together. We're going to do a couple things to set the brightness of the LEDs. We want to tell CircuitPython to not automatically write the colors to the LEDs when we set them. We kind of want to do all of that at once towards the end. We have a variable here called position that just keeps track of our position in the list of colors, and a while loop. So this while loop will run again and again and again. We're going to use the CPX module to detect if button A is pressed. If button A is pressed, we increment the position by 1 and sleep for 0.2 of a second until we skip down to here, fill the LEDs with whatever color is our current position, and then show all of the LEDs at once. If button A isn't pressed, but button B is, instead of incrementing our position, we're going to go backwards 1 color. So we can use the buttons to just kind of cycle through the colors that are on the board and make sure, well, let's see if that works. So I have this opened. I opened up the code.py file in the CircuitPython drive. I'm going to adjust this a little bit. OK. So in Mu, all I really need to do is save it. I save it, it flashes the code on there, it immediately reboots and starts running the code that I've put on there. So we start out, the first color in our list is red. We start out with red, we're at position 0. If I go in here and I press the B button, we cycle to purple. Right? B is we're decrementing, we're going backwards through the color list. So we go red to purple to blue. If we want to go forward, we press button A, and we can cycle through all of the colors. So that's really neat. Any questions on that so far? Cool. Yeah, so the way that works, we'll actually have another example that shows individual control. This one right now is just filling all of the LEDs, right? So pixels.fill, you give it a color, and it will just set all of the LEDs to that color. Individual LEDs are coming up next. So I mentioned that there's a temperature sensor on the circuit playground, right? And with a set of LEDs, you could kind of have a cool temperature setup, set it up in your house, something that will show you roughly how warm or cold it is in your house. The difference between like 82 and 83 degrees, not super noticeable, but when you get into ranges of like 80 to 85, 85 to 90, that's when you can kind of start to feel it yourself. So this is another example of doing some cool things on the Circuit Playground Express. Again, we're going to import some modules that we'll use, Adafruit Thermistor. Actually, I don't think that one's needed. But we have the CPX module is the main one we're going to be using. We define our colors. This time we're including white and black. Black we're going to be needing later on further down the script. We have our list of colors again. And what we want is kind of a display range for the temperature and the color, right? So if the temperature is less than 60 degrees, it's going to be a little bit chilly. Let's show blue. 65 to 70, still on the cooler side, we can go to cyan. The 70 to kind of 85 range is where I'm usually most comfortable. That gets a big old green light from me. 90 to 100 is getting pretty warm. And then anything over 100 will display red. Same as before, we're going to set auto right to false and set the brightness to 0.3 because I don't really want to blind everybody. And then we enter into another for loop. So this time we're getting the temperature. And the temperature comes across as Celsius, right? You get it in degrees Celsius. And this is America, and we use Fahrenheit. So we'll do a little conversion there. And then we're going to iterate over all of our temperature ranges. right? So we basically want to test the temperature that we got from the sensor. Is it less than the temperature that we're currently on in the list? And if it is, we will fill the pixels up to a certain point with that color. The rest will be black. And then we will write out our pixels and display them on the circuit playground. And if we have a temperature that isn't in this list, which basically means anything over 100, we're just going to fill all of the LEDs with red, because that is way too warm. So, pulling this back up here. So again, all I need to do is save the file in the CircuitPy drive. And when I save it, okay, cool. We have 5 LEDs that are lit. They are green, 1, 2, 3, 4, 5. So it's 70 to 75 in here right now, would be my guess. One of the neat things that you can do is there's this really nifty print statement that most languages have. And you can print in MicroPython. There's no way to see it on the hardware, but Mu has a really nice feature where you can connect via serial and see everything that you're printing. So this is actually 77, low 77 degrees. So that would be, right, less than 80. So we're green. That's the 5th one. So we have 5 LEDs that are lit. So what this is doing is it's just saying, what's the temperature? Show the LEDs. What's the temperature? Show the LEDs. And it will keep doing this as long as it has power. It's, like I said, microcontrollers are meant to do things again and again and again. And I could take this and throw it up on my wall at home, and then cool, even if I'm not near the thermostat, I can look across the room and generally know what the temperature is in my living room. All right, so the next thing we're going to take a look at is the BBC Microbit. So I mentioned this is another kind of learning platform that's been released. This is made by the BBC as a way to kind of get kids interested in microcontrollers and electronics and hardware and whatnot. Similar to the Circuit Playground, it has 2 buttons. Instead of 10 RGB LEDs, it has a matrix of 5x5 just red LEDs. And it's fairly easy to do things like control the brightness, show images, scroll text. It also has a temperature sensor and a compass and accelerometer. There's kind of a lot packed into this board for the cost. You can get a Microbit for 10 or 15 bucks online. They're really inexpensive compared to other boards with similar hardware features, and it's just kind of a fun little thing to work with hardware with. You have 3 exposed pads for connecting hardware, as well as 3-volt power and ground. Each of the little sections in between the main pads are I/O pins that would be used by something like an expansion board. So if you check out the makerspace next door, you'll see that it, we don't have those motor boards. We have different motor boards. So there's a bunch of different motor boards and different shields that the Microbit will slide into and can leverage more hardware than just those 3 pins. So what I'm going to do now, I'm going to close this code.py file, and I'm going to switch mode over to the BBC Microbit. So once we're in the Microbit mode, we have a couple of new buttons up here, one of which is Flash. So instead of having to drag and drop a Python file into a drive, you can just hit the Flash button, and Mu will take care of putting it on your board for you. All right, now, so I'm going to eject the CircuitPython, the Circuit Playground, rather. Unplug it, and all right, so we have a BBC Microbit. The code that's on here, all it does is, a little hard to see. all right. I might have to hold this. So it displays a smiley face right now, is the only thing that's on here. You can see the 2 dots for the eyes and kind of LEDs on the bottom for the mouth. Not a whole lot going on with it at the moment. But to piggyback off of the previous temperature example, what if you don't want a general idea, you want to know what the actual temperature is? And so to do that, let me open that script. Nope. Oh no, where did my temperature script go? All right, I'm gonna have to write this live coding demo. This will be fun. All right, so the way you get the temperature in the Microbit is you just, let's see, let's call this temp. For temperature, you just call a function called temperature. We want to do a similar thing. I'm actually going to go copy and paste this code because just like the circuit playground, the Microbit gives you the temperature as Celsius, and so we want to convert that to Fahrenheit. The LED matrix is all of the functionality for that is bundled in a package called display. And to scroll text across the display, you just call display.scroll and pass in whatever it is you want to show. So we're going to do this once. We definitely want this in a while loop. And then we will sleep for a second in between each time. So, got that on the screen. All right. This looks about right. Let's hope the demo gods are on my side. So all you need to do is press the flash button in Mu. And now our code is on the Microbit. And this one is reporting 77.0 degrees right now. And that's all it's going to do. It's just going to scroll the temperature across. So you kind of have a way to see it very generally with the circuit playground, or see the actual temperature with something like the Microbit. All right, so taking a look at another example. Sort of like a hello world where we scroll some text and do things like show images. There's a library, a collection of little images you can display on the LEDs. Happy faces and sad faces, arrows, clock faces, animals. There's a bunch of different things that you can display. And you can also design your own images where you basically set the brightness of each pixel on the display, and people have done some neat things with that. So in this example, we're going to import everything from the Microbit. We're going to say hi to Devfest, and then we're going to flash a heart a couple times. We're going to show the heart, sleep for half a second, clear the display, sleep for half a second. So we get 2 quick flashes, and then followed by a third longer flash where the heart's on for a full second. So if I flash this, flashes really quickly. It was almost instantaneous. Hit the button, and before I know it, my code is running on my Microbit. So hello Devfest, there's our hearts. And then we go back to the beginning of the loop and do it all again. So, examples of other projects that have been made at Root Access using MicroPython. This was a project for the 59 Days of Code Hack Halloween. It might be a little hard to read, but this was a project that you would push a button and it would give you a stupid Halloween joke. And the joke here is, what does the ghost of a programmer say? Boolean. So this was a fun little project done with the ESP32, a thermal printer that you can pick up online for 15, 20 bucks, and then in a 3D printed enclosure. So this was a couple days worth of tinkering, designing the enclosure, 3D printing that, A lot of fun. It was one of the first things that I'd ever done with MicroPython. And then 59 Days of Code also did a stupid hackathon in 2018. They did it this year as well. This is a 2018 entry. So who here has played Pong? Right? Pong is a 2D game. There's a 3D version called Ping Pong, and I made a 1D version that just runs on a single LED strip. So the ball is just bouncing back and forth on the LED strip, and you have to hit a button when it gets to your end to bounce it back. If you don't hit the button in time, then it goes past your paddle, you lose, or your opponent wins a point, and at the very end, when the winner is determined by scoring 8 points, it goes into a cool little rainbow, flashy thing, just kind of random colors to random LEDs. So this was a neat project, again, using the ESP32, an RGB LED strip, a couple of RGB LED sticks to keep track of the score, and some push buttons to control your paddle. So this was something else that was made at the hackerspace using the tools and facilities that we have there. So those are all really cool, and they're like fun little projects. But what about some real world applications, right? So here in Fresno, we have really good air. No. So the air quality in the Central Valley is an ongoing problem, right? And it's not fun for anyone. The Central Valley has some of the highest incidence of asthma, both childhood and adult onset. I actually, I grew up in LA and developed asthma when I moved to the Central Valley when I was 19. So, air quality is something that's really important. And it disproportionately affects lower income areas as well, right? The more, the poorer parts of town historically also have worse air quality. And so this is something that I kind of take issue with and want to do what I can, leverage my skills to be a force for good for something in the world, right? So I've been working with the Central California Asthma Collaborative on a community air monitoring project. This is something where we're developing air monitoring devices that will be put up and down the Central Valley in a lot of lower income areas and other areas where there is really poor air quality. What I have right now, this is all a work in progress, right? So this is still in the developmental prototype phase. But we have an IoT air monitor. It's running, again, an ESP32 with MicroPython. We have a temperature, humidity, air pressure, and VOC gas sensor. VOC gas is volatile organic compounds, so things like methane and carbon dioxide. And then we have two PM2 sensors that kind of measure the particulate matter that's in the air. When you see things like, if you go to valleyair.org and you see the AQI, the air quality index, that's made with PM2 data. And then we've talked about some other sensors that we could throw on this. We're not really sure what that'll look like, but there's more that we can add for sure. And we'll kind of figure out as we go what would make this the most useful to them in the work that they're doing so that we can give the right data to the powers that be and maybe try and make a little progress on the air quality situation in the Central Valley. So this device is set up at the hackerspace right now, reporting the air quality inside of our space in real time to a dashboard that's available. This is written also in Python, but I'm using Django for the web service and Vue.js for the front end. So the idea is that we have a map with all of our air quality devices on it, and you can click on any one and see live real-time stats for what the air is like. The one that I'm working on right now is inside, but most of these are going to be outdoors to kind of measure what the air quality is like in the worst parts of the Central Valley. So the couple of years that I've been working with MicroPython, having had no hardware experience previous to this, has kind of got me feeling like the professor, right? I feel like I can wire anything to anything. Give me a sensor, cool, throw it on a microcontroller, code it. Give me motors and LED stuff. I've had a lot of fun working with LEDs various projects. And so it's been really beneficial, right? I have this feeling that I haven't felt in a long time, right? The last time I felt it was when I was 12, learning HTML for the first time back in the late 90s. And it was just so excited, like, look what I can do. This is awesome. I can like write this code and see it on my screen. And I feel the same kind of excitement working with electronics using MicroPython that I did all those years ago. It's kind of neat. Mike Stish is the editor-in-chief of Hockaday. They have a blog and talk about all sorts of cool electronics projects. He says that MicroPython is the future of embedded electronics, and that the trend right now, everything is trending towards higher level languages like MicroPython and kind of away from lower level C and C++, because a lot of the things that you can do in Arduino C, you can also do in MicroPython, and it ends up being way easier for folks to get started doing that kind of thing. If you are interested in learning more, check out the Fresno Python user group, fresnopython.com. We meet the 4th Tuesday of every month at Root Access. Talk about all sorts of Python stuff, web development, machine learning and AI, data analysis, MicroPython for sure, and more. There's another meetup run by Jason Cooksey, who is giving several talks today that you should definitely go check out. He runs the Fresno Electronic Hobbyist meetup. They meet the 2nd Thursday of every month at Root Access. And it's sort of all things electronics, right? Arduino, Raspberry Pi, MicroPython for sure, and just kind of anything you might want to nerd out on hardware-wise. So you can get more information about that on the Root Access website. And then, of course, Root Access itself, definitely have to mention that because until Root Access began, there wasn't really a place in Fresno to come and do and learn all of this hardware stuff, right? We've kind of built up a community of passionate developers and technologists and people who just like making things, designers in our community. And it's a really cool spot to go and tinker and explore and build cool things and, more importantly, share your knowledge with the community around you. So definitely recommend checking that out. There's lots of different projects that we have set up there, several running MicroPython. And of course, Root Access is running the Makerspace track next door. And we have things on display there also running MicroPython. And that is it. Cool. So we've got 5-ish minutes. If anybody has any questions, I'm down to hang out for that 5 minutes. Or if you'd like, you can come find me later. I'll be here all day. I'll be in the Makerspace track all the rest of the day. So you can find me there, ask me questions. I'm always down to chat about Python and MicroPython and development in general, the Fresno technology scene. Feel free to pick my brain.
Can you do inline assembly with MicroPython?
I'm sorry?
Can you do inline assembly with MicroPython?
Inline assembly, I have not seen anyone do that, and I'm not sure what that would look like. Maybe it might be possible. If you were doing something like regular Python, right? Regular Python has really nice C bindings called C types, and you can write C that interfaces really well with Python and vice versa. Everything that I've done so far largely is in actual Python with MicroPython. I know a lot of libraries will obviously be written in C. I'm not sure how well that would adapt to like inline assembly. So, anything else? Yeah.
Do you know how fast MicroPython would be for computational math?
I mean, my answer to that would be it depends on the hardware.
Yeah.
I wouldn't try doing a bunch of machine learning on a microbit.
Of course.
But I mean, if you're doing like really computationally intensive stuff, I might offload that to something more adept to that, right? So send the data to a server somewhere that, sure, might be written in Python on a big beefy server, but also allows you more flexibility to drop down into like C or Go or Rust or whatever you have and kind of do your really computationally intensive stuff there. I guess it depends on what you actually have in mind as well.
Yeah, in this case, it'd be like embedding a physics controller into like a piano, for instance. So it'd have to be completely offline.
Sure. Yeah, definitely. Yeah, again, I would say it depends on your hardware.
Yeah.
I know that like some examples, some of what Adafruit does, like the PyGamer and the Neo Trellis M4 that I had up on here earlier, those both use an ESP32, but it's using it as sort of a coprocessor. So all of your main code happens on their SAMD, whatever the numbers are, that's running CircuitPython, but it has the ESP as a coprocessor that lets you connect to Wi-Fi and kind of like offload tasks to another piece of hardware. So a setup like that might work, where you kind of have like your main control loop on one processor and your intensive stuff kind of running somewhere else connected.
Okay.
So.
Yeah, I have two questions.
Yeah.
One, what does the community kind of look like for the STEM32 F4 boards for MicroPython?
For the which ones?
The STM32 F4s.
Yeah, so I haven't used the STM boards. I kind of got my start with the ESP8266, and when that wasn't enough, more research led me to the ESP32. So most of my experience is around those boards. MicroPython runs really well, and they're really popular in IoT applications, but I haven't really used the STM hardware all that much.
Yeah, also, where do you actually get your ESP32 boards?
So the ESP32, you can get them on Amazon. You can usually get like a 2-pack for $10, or you can go the AliExpress route. You can get an ESP32 for like less than $2, but you're waiting 6 to 8 weeks for shipping. So you can pay a little bit more and get it sooner, or pay way less but wait a little while longer to get it. So, but yeah, AliExpress is where I get most of mine. So, excellent. Thank you, everybody.